Hello, we are Group 26, and for our Ceng 461 project, we chose to model deer behavior using Markov chains. The purpose of this project was to model male and female white deer behavior around a pile of apples in the forest. This was done using Markov chains. The Markov chain models that we found accurately represented deer behaviors that would be expected for this time of year. We found that once one female deer was observed, the probability of seeing at least one more greatly increased. Also, the probability of seeing at least one male deer is greatly increased when at least one female deer is present. This picture visually represents the project. As you can see, there are multiple female deer plus one male deer around a pile of apples in the forest. The data for this project was manually recorded over 30 hours between November 11th and November 14th, 2017. It was done in the Kettle Valley region of British Columbia, Canada. The Markov chains were used to describe the numbers of both male and female deer seen in this area. The probability of seeing a female or male deer was calculated for any given time step. White-tailed deer were observed from a tree blind around a pile of apples for a total of 30 hours. The data includes the times different deer came and left the area. On each of the 4 days, observations were made from 6 a.m. to 9:30 a.m. and again from 1:30 p.m. until 5:30 p.m. This was due to the fact that deer are most active in the early morning and the evening. The data is broken into 15-minute time steps for the purpose of creating a Markov chain to model the information. This slide shows the raw data that was collected during the time frame. It shows when each female and male deer arrived and left on each of the 4 days. This is a visual representation of the tree blind used in this project to observe the deer behavior. This map shows the region in BC where the project data was observed. This Markov chain models female deer behavior, where each state represents the number of female deer in the area. In state 0, it can be seen that if there are 0 female deer in the area, the probability of there being one female deer in the area is very low. However, if there is at least one female deer in the area, the probability of seeing more greatly increases. This Markov chain is the first of 5 that models male deer behavior with different number of females present. In this case, with 0 females present, a male deer was never observed. With 1 female present, the probability of seeing a male greatly increases. However, if one male is present and another male arrives, the probability that one male leaves is very high. With 2 or fewer females present, the results of the probability of a male arriving were the same as with 1 female present. With 3 or fewer female deer present, the probability of one male arriving increases. With 4 or fewer females present, the probability of one male arriving is the same as in 3 or fewer females present.
So next we had to create some state transition matrices from the Markov chains that we had. We created 6 state transition matrices, 1 for the female Markov chain, and then 5 for each of the male cases. Next we had to assume that our model will reach steady state, and use steady state analysis to find the probability that a given number of female deer will be present. From this, we're also able to find the probability of a male deer being present. This slide is a continuation of the calculations from above. After completing the calculations, we found some of the probabilities for a given state of female deer. There's a 67% chance there are no female deer present, a 6.7% chance of 1 female deer being present, an 8.1% chance of 2 female deer being present, a 10.8% chance of 3 female deer being present, and a 7.37% chance of 4 female deer being present. Once we knew the probability of being in any given state for the female deer Markov chain, we were able to use each of the Markov chains for the male deer to find the probability that at least one male deer is present while you're in that state for the female deer. Lastly, we took the total of the probabilities of seeing a male deer in any state and found the probability of seeing at least one male deer regardless of how many female deer are present. This was found to be approximately 9.08%. Our data and calculations show some interesting deer behaviors that are also what we would expect to see in the natural world. We believe this shows that our model is a good representation of wild deer behavior. For example, it can be seen that deer travel in groups because once one is observed, the chance of seeing more is increased. During this part of the year, male deer are primarily focused on pursuing female deer, so the probability of seeing a male deer is increased when a female deer is present. Male deer are also fiercely competitive, so if a male deer is around a female deer, the probability of a second male coming is increased. We can also see that the two male deer will not stay in the same area for more than one time step, as the smaller of the two will have to move along. From our Markov chains, you can also see that the chance of seeing a male deer is increased as the number of females is increased. Although no male deer were observed while there were specifically either 2 or 4 females, we believe that if more data was taken, the probability of seeing a male under these circumstances would increase from the previous state, and there would be a more linear increase in your probability of seeing a male across the states of females. In conclusion, the Markov chain models we created from the data observed accurately describes deer behavior. This model also fits with known deer behaviors for this time of year, so we believe this shows our model is a good approximation. The steady-state probability of seeing a specific number of female deer is shown in the table in the next slide, and the steady-state probability of seeing at least one male deer, regardless of how many female deer are present, was calculated to be approximately 9.08%. This slide summarizes our final findings. Thank you for your time. I hope you found this presentation informative. We can edit afterwards. Oh, there it is.